There we go. All right. Okay, so let's keep going. So here are just two examples, okay? Notice that the first one here does pass the vertical line test. I mean, let me try drawing a bit. I mean, there are vertical lines. Well, yeah, let me not draw there. Let me just erase that. There we go. But hopefully from a non-vertical line, it might take a little visualization, but hopefully you can see that any vertical line I draw will cut through this graph only once. Okay? Any vertical line I draw will intersect this graph no more than one time. So this line is the graph of a function. In fact, any non-vertical line is the graph of a function. Okay? Any non-vertical line is the graph of a function. So we have this. Notice here that the circle is not a function. It's not the graph of a function. Because you can see there's a vertical line here that intersects the graph twice. I mean, here we have a vertical line that doesn't intersect the graph, but this vertical line intersects it twice. So because of that, a circle is not the graph of a function. So in particular, non-vertical lines are graphs of functions. And again, if you wanted to get input and output, you would just look at ordered pairs, that is the points on the graph. So it might be kind of hard to see, especially since I drew well, let's go here. So if 0 is your input, right? You can see that -1 would be the output because the point 0, -1 is on the line. Well, that makes sense. So we have that now. A circle, you don't do that. Now, why does the vertical line test even work? Well, hopefully this will help you see why. I mean, the whole idea is if you take a vertical line, every vertical line is the graph of the equation of the form x equals b, for some number b. So every vertical line is the graph of an equation that looks like this. So if any point on that vertical line has x coordinate b, in this case, well, if this vertical line intersects the graph, say this graph, twice, those points of intersection have x coordinate b, as you can see. So in other words, you have two different points, or more possibly, with the same x coordinate. We saw that can't happen. Now, with a graph, just like a relation, you can't have two ordered pairs with the same x coordinate, but different y coordinates. Because then this is saying that B goes to C and B goes to A. Now, I'm not going to draw the whole correspondence diagram, but in this case, though, you would have B being assigned to C and B being assigned to A. If you had the correspondence diagram, but you can see that this can't happen. This cannot happen. B is an input, but it has different outputs, so that's impossible. So for a function, that can't happen. That's the idea why the vertical line test actually works. Okay. So basically, if you want to sketch the graph of a function, you want to sketch a graph that is the graph of a function, you just want to make sure it passes the vertical line test. You don't want to draw a circle. You don't want something like this. Okay? And there are many examples like that pass the vertical line test. We have this function. We have y equals x cubed, for instance. Okay. Now we have y equals x cubed, so that's a function because it's, the graph of it is the graph of a function. Hopefully you can see that any vertical line you draw will intersect the graph at most once. In fact, let me draw some actually. So that's red, so let me just change the color a bit. Make it this. There we go. Now, if I draw a vertical line, hopefully you can see from me drawing this that every, see, vertical line is intersecting the graph only once. So this graph does give us a function. It's actually the graph of this equation down here. It's actually the graph of that equation. Here, the graph of y equals the square root of x. I'm not sure if I drew that for you guys, but it's here now. This is also, the graph here also gives us a function. You can see that any vertical line you draw might not intersect the graph. As you can see, this one doesn't. But any vertical line is only going to intersect the graph once. So this does define a function. We can get a function out of this. So we do have a function. So that vertical line test is very helpful. Now, we can see that from a graph at least, you can get a function. Okay? So you just have to make sure the graph passes the vertical line test. Okay? What about equations? Well, you can get a function from an equation in x and y. I mean, the book goes a little bit more into it, but essentially it just boils down, at least with me in this class, it boils down to this. You just sketch the graph of it, and the graph has to pass the vertical line test. Then we have a function. What we really have is y as a function of x, which is actually what we've been doing. I think I might have said that before, but we actually have y as a function of x. So again, if you have an equation in x and y, and you want to know, do you have y as a function of x? Meaning for each input x, so do you get only one output? In other words, do you satisfy the definition of a function that we saw already? Well, sketch the graph of it, and you have, and if the graph passes the vertical line test, you're good. Right? You're good. In the notation, let me go back to notation real quickly. Here, in the notation, actually, we have y is a function of x. I think I said it here, but we have this. When you have y as a function of x, we have this. And we say y is a function of x, so I did have that. So what we've had so far is y is a function of x. And again, since y is a function of x, if f is that function, you can actually replace y with f of x in the equation. In other words, if you're able to get y in terms of x, you can actually formula for that function. You can actually get a formula for that function. And what the formula does is it's telling you, at least algebraically, how to get your output from each input. I drew this also. You know, just hopefully it would make more sense here. That's really what's happening here. The formula tells you how to get your output from your input. We'll do examples, don't worry. I mean, what's really happening in the background is what we saw already. Namely, if you have an equation in x and y, its solution set is a relation. Right? A relation is just a collection of ordered pairs. Well, what about the solution set to an equation? That's a set of ordered pairs. So that's a relation. That's a relation then. Okay? So basically what you're seeing is does that relation give us a function as we saw earlier? And really you can look at the graph and check and use the vertical line test. That's basically what we're doing here. Yeah, I hope that makes sense what I'm trying to say. So, all right. So we have that example now. Okay, that's good to know. So again, from an equation in x and y, you can get a function. Y is a function of x. You can get a function. In fact, here's an example if you looked at this here, 4x minus 2y equals 12, you actually can get a function from this. I mean, I did say it already that a non-vertical line is the graph of a function. And the graph of this is a non-vertical line. In fact, just to really illustrate this, if you were to graph this, we have this, as you can see. You know, we have a non-vertical line here. And basically here, what you can see is that we have y as a function. We can get y as a function of x. If you solve for y in terms of x, which is actually what I'm doing here, we actually can get a formula for a function. Namely, we have this. So this is basically telling us that to get your output from your input, okay, you take your x, multiply it by 2, and add -6. And you're adding -6. So that's what we have here as our function. So we have our formula here. Okay. Not only that, f of 1 here, right? So this is just an example I'm doing. Basically, if you wanted to get f of 1, right? So 1 is your input. Your output then would look like this. You have -6 plus 2 times 1, which is -4. So this is basically saying that 1 as your input gives you back -4. Let me draw that actually. So from here, you get 1 as your input. From this function, you get back f of 1, as you can see, which is, in this case, -4. So your input is 1. The function gives you back -4 as your output. That's what we get here. And then I do the same thing with 2 as well. Okay? Namely, if we have 2 in here, by the formula, f of 2 turns out to be -6 plus 2 times 2. So we get -6 plus 4, which is -2. So in other words, 2 gives us back f of 2. There we go. 2. What the? Which is, let me just fix that up. There we go. I'm just trying to draw what's happening, as you can see. And so from f of 2, we get -2 as our output. And here I'm just saying if you were to graph it, every point would look like this, or x. So let me stop the recording. I'll show you the graph again. Let me just pause the recording. I'll show you the graph again.